Now, for the latest feature for Frame developers, we have Kian here today, who is lead engineering at Parity Tech, who is also a Polkadot Fellowship member, but more importantly, who is working on one of the Jam implementation as a member, and that is, are you not?
Yes, I am.
Yes, you are, right? Yeah. Very exciting. But today, about Frame,
yes.
Take it away, sir.
All right, thanks for the intro. I think this venue and this vibe is pretty amazing, so also a shout out to all the organizers and Web0 for putting this together. I'm really enjoying being back in sub0. So the title of this talk was originally Frame in year of 2024 and what has changed, but admittedly it's more broad about Polkadot SDK as a whole and not just Frame. You can find this talk in Markdown format, also in this URL with some speaker notes and so on that we can use as further reference. So the first very foundational and important thing that I want to cover is that Polkadot SDK now finally, with the monumental effort of many people, one of whom is here, Oliver here, has what I would call stable and meaningful releases in that it's being released on a fixed cadence and things are being bumped in a semantic version while adhering to semantic versioning, which is very important and helps our developers immensely. So let's look further into how that looked in the past. So before Polkadot SDK was a thing, and we had 3 different repositories. It was Substrate, Cumulus, and Polkadot, which also contained XEM, and together they were together what we would need to develop on Polkadot. For years, we were using Git-based dependencies, which is very primitive, very basic, very ugly. I think we all had to deal with those horrendous cargo update -p, and it was like very, very bad. At some point, we had releases and versioning, but we were doing this thing that I used to call YOLO bumping everything, as in every month, every year at some cadence, we would say, okay, it's time to update, everything would get a major bump, because we were not really tracking if a particular crate is being changed in a breaking version. Is it just getting like a patch? Is it getting just a fix? And so on. We weren't like really tracking this major, minor patch semantic versioning situation. But right now, it's not like that anymore. So this is a screenshot of the Polkadot SDK README. It has this section with some information about releases, indicating what was the last stable release and what is the next one with its date, with some links, and I highly advise you to look into this further. So how does this look? A few more details. There is, so the releases are named stable, then 4 digits, 2 for the year and 2 for the month. So currently we are in the release cycle stable 24/7, we would be, and we're in the process of releasing stable 24/12, which is the last one for the year, which means we will get a new release every 3 months. So the plan is to have a stable release every 3 months. These releases will be also updated for a year, so you can count on using them for a year without things going out of date. You would receive the security updates or the important patches. And again, very important is that now if you track the development of things within the maintainers of Polkadot SDK, or if you happen to be one of them, you realize that you have to adhere to this PR documentation system, PR doc. Every PR has to be tagged with some information about, what crates am I touching? Is it like a major update? Is it minor? And this is the foundation of how we can have this meaningful releases, because we no longer have to, major bump everything, and you have to, as developers, as users of Polkadot SDK, you no longer have to update everything, because only the crates that have received a breaking change get a major update. That went away. So the source of truth for everything release related is also a repository called Release Registry. Here you can find the dates of all the releases and the plans, and what are the patch dates. If this is all new to you, which is understandable, you should regularly check this repository. Okay, something else I want to cover is that we've also, while transitioning from Substrate to Polkadot SDK, we have also revamped a little bit our getting started story. And there's a section on README with some information on that as well, which I wanted to highlight. But I want to go into further detail of 2 of the components here, mainly our Rust API docs and our templates. So first, talking a little bit about the templates that we maintain nowadays. Again, if you were around in years 2018, 19, 20, you remember a template called the substrate node template. This was our OG template. It's no longer around. I guess that's bittersweet news, but it's where we are now. And it's being replaced by 3 templates that are maintained as a part of Polkadot SDK, and the names are as followed. So our first main product, and the one that we give the most attention to, is the Polkadot SDK parachain template. Again, a parachain template used to exist in the past as well. This is just a new version of it. We still maintain what is analogous to the old substrate node template. We call it now the Polkadot SDK solo chain template, which I think is a better name in that it describes it's a solo chain that is built with Polkadot SDK. And we have a new one that is focused for education and testing, which is minimal. So it's like a much more shrunken version of it. These 3 templates are part of Polkadot SDK, but they are being automatically updated into 3 repositories that you can easily fork and use as an actual template on every stable release. So they're also guaranteed to always be up to date with every stable Polkadot release. So it's no longer the case that someone has to maintain it, or sometimes this substrate node template used to be out of date because no one happened to be updating it for some time. For these 3 templates, this is not the case. They're always up to date systematically with the latest Polkadot SDK release. So you can be sure that they're using the latest features, the code in them will compile, and so on. But what's the case about them is that being part of Polkadot SDK, and we as the maintainers of Polkadot SDK, we're not particularly trying to not go into a strong opinion about what product you should build with these templates. They are rather unopinionated. So outside of Polkadot SDK, we actually do have templates that are maintained by other teams. 2 of them I'm naming here, Pop, who is present around, or Open Zeppelin, that are more opinionated. They have templates that are specifically for things like an EVM parachain, or I don't know, a DeFi parachain. But these are things that we don't build as part of the Polkadot SDK maintainers. We expect the community to build, and it's what we're seeing here. Okay, so new templates. Then I want to point out that if you open one of these templates and you look at the cargo.toml, you will notice a difference, something that I am personally very happy to see. So the cargo.toml of a Polkadot SDK runtime right now, at least one that is updated to all of our latest features, it looks like this. Much, much smaller, and with much smaller possibility of error than what we had in the past. There's no longer this list of like 37 dependencies of substrate primitive Merkle this and substrate primitive database that. It's one crate called Polkadot SDK. That's very nice. So highlighting on this part of it, the highlighting is a bit bad. It's only the Polkadot SDK part. So Polkadot SDK crate is one umbrella crate, mostly meant to simplify your cargo.toml. So instead of bringing crates independently, you can bring the crates that are within Polkadot SDK as just one dependency. And this simplifies a number of things for you. First is that the versioning becomes simpler, as in because you're not bringing in 37 dependencies, you don't need to specify 37 version numbers. You only specify the version of one dependency. Then at least when you're developing your runtime, you're familiar with this system or situation where you have to define a STD feature, and then you have to enable the STD feature of some dependencies and so on. And if you miss one of these things, you get this very nasty compiler error. It's very hard to pin down. We all hate this. So now this is way less likely to happen with features like STD runtime benchmarks or try runtime. So enabling playing with features also becomes simpler. One question here is this going to kill my compile time? And the answer is not in a significant way, as in this crate has been developed in a way that is aware of the fact that you might want it for developing your runtime, or a node, or both, and it has feature flags that control which dependencies it brings in. Actually, if we look at the example, maybe we can see. So here we're bringing in using this crate with a feature called runtime, which signifies only bring in dependencies that are for runtime development. And then separately, if you want to use specific palettes, you also have to specify them as features to bring them in, because a runtime doesn't use all the palettes within Polkadot SDK. So with these techniques, your compile time would also not get impacted in a very significant way. And also using it for the first time is actually quite easy, again, because of the way it's been developed. You just have to go and clean your cargo.toml. Your code remains as is. You just use Polkadot SDK star, so bring in everything before all your dependencies. And in 99% of the cases, this would work as is. So this is it with the Polkadot SDK umbrella crate. Now, if we look at the runtime lib.rs, so the definition of a runtime in one of these templates, we also notice that there is less code at the top of it. It looks like something like this. So the part of this that I like is this part. Specifically, within this Polkadot SDK crate, there happens to be something else called Polkadot SDK frame, which I'm importing as frame. And then I'm saying just use frame prelude everything. Or in this case, because I'm developing a runtime, I'm also adding use frame runtime prelude everything. And this removes the need for you to bring in, again, a million random types and traits and so on from different places for most cases. I mean, with how preludes work in Rust, it's not, there might be cases where you need more types that are not present here. But the goal is that a standard palette or a standard runtime can be written mostly using these preludes. So in the same way that the Polkadot SDK crate was a means to simplify your cargo.toml, the Polkadot SDK frame crate is a mean to simplify your main lib.rs with imports. By the way, I think the crate called frame was taken on crates.io, so we use Polkadot SDK crate. I don't know how to get it back, but it sucks. I wish this was called just frame. But it's called Polkadot SDK frame. So it might be good to just get a better idea. Look at the old version of like a substrate node template. So the lib.rs used to look like this. Again, you had to like bring in all sorts of stuff from different places. Most of the time, people, of course, get around this with copy-pasting or like with a very strong IDE to give you hints as to where the imports are, so you can get around this. But again, I don't think any of these were things that we as developers loved in the past, and now they are easier and better. Similarly, old cargo.toml of a substrate node template used to look like this. Again, and if you miss one of these STDs and you're not familiar with it, good luck. All right. So something else that over the course of the last year or two we've tried to improve is to acknowledge that, Polkadot SDK is, I actually counted it or looked at it recently, it's 550 crates with probably, hundreds of thousands of types and traits and macros and so on. A lot of it is, let's say, not well documented. But the point is, a lot of it also doesn't need to be well documented. Like very few people want to dig into the depth of this SDK and work with like the very low level stuff. Contrary, most people interact with like some of the types that are all over the place, or the frame macros. These things would be very useful if these things are very well documented. They have lots of examples, so people can work with them in an easier way. And this is something that we have improved over the last year or two. And now that we have things released on crates.io, with every release there's also documentation on docs.rs that gets updated automatically. So here I have just a simple screenshot of, like if I hover on the type storage value that you have to specify in most palettes to define like a state item. And this thing has like number of generics that specify, for example, if it's an optional value, if it's like a default value, like different syntax that you can have. All of these things are now documented in a way that you can easily access it, either with your IDE or if you go to docs.rs, you can find similar high-quality documentation with live examples that demonstrate how all of these common types are used. And something that I've seen, I think, in an empirical way, especially being part of PBA or talking to developers, is that it's not often known, it seems to me, that, or put this way, I think it's not often known that like the platform like docs.rs exists, and it has a very powerful search bar. And if you go there and actually search for a trait that is used in Substrate, you will actually find the definition of it, the documentation of it, and all of its implementers. And it's actually very powerful. So we've tried to improve on this low-level documentation matters. One thing to note is that all of the documentation of the published Polkadot SDK releases are, of course, on docs.rs, and the master branch, which is the latest, is hosted in our GitHub, on a GitHub Pages website. And we have some work there left to be done, as in we have some crates that are documentation only, but we can't publish them to docs.rs yet because of some technical issues. So there's a bit of leftover work there. So I think I already hinted at this before. Most of this documentation is also written in a way that is, it's like inside of Polkadot SDK is guaranteed to be correct, and it's not going to be out of date in any time soon. So that's also a property of these API docs. So the combination of these things that I covered, so good, stable, meaningful releases, good templates, good API docs. If I want to reflect on it, I would say it's a big step for Polkadot SDK to move away from being this chaotic SDK that takes pride in being edgy and hard to use, more toward a mature, stable library that you can actually rely on. If you build something with it today, it's not going to break tomorrow. It's not going to break over a year. As we saw, because of our release cadence, it might break after a year, or it might not be updated after a year, but a year is already like a big improvement in that regard. And we should keep it this way. Or I say we shall keep it that way. I will, from my position, I would do my best to keep it this way. I think we're at the point where Polkadot should value stability way more than being a tech frontier. So actually, originally, I wanted this talk to be a deep dive on these things, but I changed my mind because, as I pointed out, we have tried to improve the API docs for our features. So I don't need to actually go on stage and explain them anymore, but I have a list of new frame features, and all of them are linked to their API docs with examples and what they do. I will just go over a few of them, or maybe I can talk about each of them very quickly right now. So we have finished something as part of Frame that's called dev mode, which removes a lot of the constraints on Frame, so you can develop a palette without needing to specify every little bits and piece yet. So it removes the need to specify weights, indices, and so on. We have developed a set of macros that basically mimic defaults for associated types. So your config trait can now specify what is my default. So the config trait of the balances palette specifies what is the balance type. Is it the U64? Is it the U128? Now you can specify a default for these things, and your users can also then import and use that default without needing to specify it. We have developed a new macro for defining a runtime. So the construct runtime now has a new version, although the old version is also supported. They're not completely at feature parity yet, but the new one is much more analogous to real Rust syntax. I would also like to cover maybe the last one a little bit. So we are about to finish implementing something called the view functions, which is an abstraction over your frame storage API. So this is something that we have realized or re-realized that could be very helpful for the ecosystem. Because when you're developing an app with be it PAPI or PJS API, right now your only way to interact with the palette is to read the state, like you read the storage items. But truth is, palette developers very often write their palettes, or they should write their palettes, thinking about what state layout is optimized for the palette's runtime code, and not necessarily for the UI. Or it's very hard to find the right balance between the two. The view functions are an abstraction over your state, so you can say, my state is like this, but I provide the stable API on top of it, which ideally should not change. And even if I change my state layout, this API would remain stable. And these are the view functions. So this should be merged, I would say, by the end of the year, hopefully. So I have an example also of this defaults for the config traits. So this is an example of how we used to bring in frame system in a test setup, something that you have to do in every palette, or the test setup of every palette. Now it would look something like this. So you can just say, bring in all the defaults from some specified path for me, and the macro would take care of this for you. It's a useful tool to remove some boilerplate. So this was all about frame. Now let's also talk about something new on the node side. So I think, again, most of the people who use Polkadot SDK used to use Substrate are doing it to develop a runtime. They want to code on frame and build a runtime. Very fewer people are interested in customizing the node. But in the past, the solution that we gave to people was a full node template with a fully customizable node baked into it that you have to maintain, you have to, and it has to compile every time you want to compile your project. It was just well, for some people a feature, but for some people a burden that was forced on you. So how cool would it be, how good it would be if we could skip this, and we would have a node that would perhaps be a binary that you could just download and it could run your WASM runtime for you. And this is something that we've working on throughout 2024. We call it the Omni node, so one node that can rule them all or run them all, we shall say. And it's at a point where the first version of it has been merged into master, and we're targeting the next stable release of Polkadot SDK, so 24.12, for the first version of it to be released. And I have some early documentation on it that you can find in this link. The Omni node is a product that is targeted mainly toward parachain nodes. So it's basically a parachain collator node that can run most parachains. There are some assumptions, of course. If you're a parachain who wants to customize the consensus or do some very low-level customization, this won't work for you. But most teams don't want to do this, and for most teams, this Omni node would then work. Other than a parachain, it can only run a runtime locally for testing. It can, for example, run a solo chain with Grandpa and so on yet. We have it in the roadmap, but it's not the first priority. Okay, so that's it for the talk. I have two closing remarks. One is that a lot of the initiatives I've mentioned here are things that we have started. We are at a point where they are ongoing, but there's further refactoring needed for them. In that the feature is there, but we haven't refactored all the existing code to for example, meet this new specification. We still have a lot of code in Polkadot SDK that doesn't use our own umbrella crate. We have a lot of code that uses the old macro for this. And all of these things are very good mentorable issues that we also usually tip from OpenGov, and are a great opportunity for someone new to come and contribute to Polkadot SDK. So an invitation to everyone to come and help out with them. I have some links in my speaker notes about which issues fit this criteria. And secondly, as I said, I think Polkadot SDK has improved a lot, and it will get better, and I'm happy to share them. But I think it's a very important comment at this point to be happy that things are getting easier with parachain developer, but acknowledge that it would probably never be as simple as just developing a contract. And I think as builders, you should be very aware of is this trade-off worth it? The extra power that the parachain gives you, is it something that your business, your use case actually needs? So especially as we're moving toward, sorry, running out of breath. Especially as we are closing in on officially having EVM-compatible smart contracts on Asset Hub, so natively on Polkadot, I think this is ever more an important question for every builder to ask themselves. Is my use case best fit as a blockchain, as a parachain, or as a contract? So that's something to take from this talk. So that's it. I think I have time for maybe questions or, yeah.
If there are any questions in the audience. Any questions over there and here from Rob?
Oh, wow.
Hey. Testing.
I can hear you, though.
Okay. Okay, it's on. I have one question about the new cargo toml for runtimes. When you showed the previous, you had a bunch of imports, including those 4 runtime benchmarks. Does that get pulled in automatically with the new set of imports, the benchmarking infrastructure, or is that a separate thing?
No, I think that the example I have here, so the example I have here is from the minimal template that doesn't have the benchmarking boilerplate here. So what you are missing here is like one feature called runtime benchmarks with just enabling Polkadot SDK runtime benchmarks, no longer needing to enable runtime benchmarks on, again, a set of crates that you kind of have to know. Yeah. But this is the simplest example of it.
So with regard of the view functions, if I understood correctly, what you're saying is that as of today, like dApps, what they have to do is like they need to create these abstractions because they need to derive a lot of state from storage.
Yeah.
Sometimes this state is, like the vote of like they have to do some magic. And the idea of the view function is like let's use runtime APIs to kind of abstract away this from dApp developers so that we can kind of do the data aggregation and spoon feed them kind of like what they need. Now, the real conundrum for me in here is like one of the things that we do in dApps is we not only do the data aggregation, we also worry about when we have to query this data. So when is this data changing? How often we need to query it, right?
So as a part of this feature, we have a plan to make the runtime API subscribable. So very much like you call this runtime API or this view function, and if there's an update, you will be notified.
But they are calls, they are pull-based by definition as of today.
Yes. So today they are not subscribable, but we will make them subscribable.
And then inside the runtime itself, it will handle when, like, it will know when to reactively send an update?
Yes, yes.
Is there an ATA for this?
Not that I can, no. But
OK, thanks.
So this was further detail on this view function thing, which is I didn't cover a lot because, again, it's like an unmerged PR at this point. But within the next few months or so on, we will communicate more about it. It's an important one.
All right. If there is no more question, Kian, thank you so much.
Pleasure.
Our next talk will be until 4. And if you're hungry in the meantime, they're serving food on the first floor. So see you again back here at 4.